do u sub 9 over u sub 8. So in the formula up top, for the numerator, you're going to substitute 9 in for n. So it's going to be
oh, so it like goes for like denominator and numerator.
Alright, so calculate that, and then calculate it for 8.
So does
Alright, where we're getting to is what is going to be on your test.
this?
No. So I'm trying to move fast through
Wait, all of that.
over all of this.
Wait, this
Got
kinda
it?
makes more sense.
Okay, we're not gonna calculate that.
But you basically just plug each one in.
Correct.
It's simple as pie.
Yeah. Where you're gonna make mistakes at is making sure your calculator knows order of operations. That's where you're gonna make mistakes at. Alright? Okay, let's get to 41. Okay? Now, these are important. Alright? 41 says, for the sequence, and U1 is -4. Can you write the first 5 terms? Well, there's the first one.
That's given.
That is given. Can you write the first 5 terms?
Oh, so you just like plug it in.
Plug it in. This really should be like 41. I'm gonna change mine. So let's use it.
Wait, I'm a little confused.
So we don't need to know how to do 35, 39.
Right. Alright, so u sub 2 is gonna be 3 times -4 plus 2. U sub 3 is going to be 3 times 10 plus 2.
By 10.
U sub 4 is going to be 3 times 32 plus 2.
Why? Oh, it's just the answer you get each time?
Right, the previous term. 98. And U sub 5 is going to be 3 times 98 plus 2. I could probably just look at the answer.
196.
Alright, except that I didn't make that a negative. So the answer is, it's okay, y'all get it?
Was you not making
But it's
it?
This was negative,
You and you.
but I neglected to make it a negative. It's okay, you get it.
Wait, so you sub it, you plus 3 times the previous.
Previous term, u sub n minus 1 is the previous term.
Okay. Oh my gosh, I know what choice it is.
Got it?
So you kind of just use like more grapes.
Alright, now look at 43. We're going to write a formula given this information. Okay? U sub 1 is 3 and a common difference is 6. Alright, so arithmetic. What is the recursive? Ladies and gentlemen, arithmetic, what is the recursive?
Oh,
UN equals
U1 plus
N minus 1 plus D.
Oh.
What's the explicit?
UN equals U1 plus difference to N minus 1.
Yes. All right. Geometric. What's the recursive?
U to the N negative 1 subset and then times R.
And what is the explicit?
times R to the N minus 1.
There we go. All right. So for 43, U1 is 3, D is negative 6. We're looking for the explicit form.
So U sub U sub 1 equals
U sub n.
U sub n equals 3 plus 6 negative 6 times N minus 1. So you
Just do the algebra.
Yes, Leah.
she really had I feel up to
Got it?
Okay, you just
you win.
45 is also a great problem. 45. All right, does everybody have this?
Wait.
I'm waiting. Actually, let's do 46 instead of 45.
I'm good.
I want to do 46 instead of 45. They're the exact same. 46 is a little harder. All right, it's arithmetic. How am I going to come up with the formula?
Well, we do. Oh! I don't know. I actually don't know.
The subtraction thing?
Yeah, what is it? Yes, come on.
I know what it is, but I don't know which one's X. Oh, wait. Is it U?
Here's the x's.
0 minus negative 1?
It'd be negative 1 minus 2 over 7 minus 3. And what is that going to give me? The D. The difference, yes. The change in y over the change in x. You could have done 2 minus negative 1 over 3 minus 7 and you'd still get the same number. So that's negative 3 over 4. So that's negative 3/4. That's my D value. What is the D? It's also the slope.
Yes.
Okay, that's good. So I know that my equation better look like, right? That's what I'm expecting it to look like. Plus some y-intercept. Okay? Now, look. Here we go. Here's my formula. But how do I get to U sub 1? What?
plug in
What do I plug in?
U3.
Okay. So I'm going to go
The difference.
U3 equals
Negative.
U1
Yeah.
plus negative 3/4 times 3 minus 1. And I'm for U3, I know it's 2. So I'm going to solve for U1.
So we can move negative, we can like do negative 3 times 2 and then move it over.
Wait, that's explicit?
This is the explicit form to solve for U1 because I need U1 to get to my equation.
So if you need to solve for U1, you always use the explicit because that's the only one that has it.
Correct. Once you get the difference. All right, so this is 2 equals U1 plus, that's 2. So what is that? That's negative 3/2.
Mom, is Ruth here? Is she here?
Is that negative 3/2? Now add your 3/2 on both sides and tell me what U1 is. Somebody do 2 plus 3/2. Yeah,
9
it's-
halves.
It's 9/2. Because it's a negative here.
Oh, yeah.
Oh my gosh.
So we're adding it. So it's 9/2. All right, so then we have, let me erase this. This was, all right. So then we have UN equals the first one, 9/2 minus 3/4, because our difference is a negative value, times n minus 1. So if UN equals 9/2 minus 3/4 n plus 3/4, what's 9/2 and 3/4 more? And that's what's going to go here. And we could have left this not y equals but UN. What's 9/2 and 3/4? Y'all can do this in your calculator. 9 divided by 2
19
plus,
fourths.
what'd I say? 3/4. Math. 21/4.
No. I knew that.
I just did it in my calculator.
Oh my gosh. How did you do that? I just solved the problem.
All right, does that make sense?
Oh jeez, I know.
Okay, you're going to have to work problems like this. Got it? Has everybody got it?
I think so.
Okay, look at number 47. Now we have to find a partial sum.
We need to know all those equations.
Yes, 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 yes. You have to know those equations. Recursive, explicit for both arithmetic and geometric.
No, the one for the summation. Like if you
Okay, I say no because you can do this, and as long as you can write the explicit form of the equation here, you can put in your calculators. Okay, which is the way I would work 47.
Oh my gosh.
What is the 12th partial sum? So k equals 1 to 12.
Wait, could you repeat what you said before you said that? You said if we can do
The explicit.
If you can do the explicit form here, then you don't have to memorize the formulas for partial sum.
So the explicit.
you can just do the summation,
You can just do the summation in your calculator.
but what do you
Okay, where are the formulas? If you look back on page 66, partial sum formulas are on that page.
Wait, I don't understand. So like when I would put that in my calculator, right?
Well, we got to get the explicit form.
From the numbers that we have in there.
Well, we haven't finished.
So we know.
U1 is -3. U12 is 16. Yes? The sum, it's, let me just, math num, I think. And it's way down? Nope, that's not
it's
correct.
okay. You have to go change to your function to sequence to get n, remember? Right?
No,
And then-
no.
You just go around.
It's just math, go down to number 10.
But mine was whenever I was pressing n, it was showing x. Does it matter?
It does not matter.
Oh, so I changed my function to sequence so that mine showed n. But that was unnecessary.
You don't have to, no.
Should I change my mode?
It doesn't matter. Okay, now we need the explicit form. So what do? I need the slope.
So.
I need the difference.
16 plus 3 over
16 minus negative, which is plus 3 over 12
minus 1.
minus 1, so that's 19 elevenths. Such a weird number.
So then we have.
That is so strange, y'all. Okay, so that's my difference. Can I get the y-intercept? If I'm adding 19 elevenths from U1 to U2, then how do I get back to U0?
You subtract.
Subtract. So take negative 3 minus 19 elevenths.
What do you get?
What do you get? Negative 3 minus 19
Negative
elevenths.
52
Math,
elevenths.
num num. Okay, negative 52 elevenths. So it's going to be y equals the slope and it's minus 52 elevenths. So if you can put that here, 19 over 11 x. So I put that in parentheses. Minus 52 elevenths.
How did you get that from the
That's
explicit?
explicit.
Yeah, because this is the y-intercept.
I thought that was.
U0 is the y-intercept.
Yes. Okay, so you could have done this. Un is negative 3 plus 19 elevenths n minus 1.
I did that.
All right, and you got un equals 19 elevenths n minus 52 elevenths because it's negative 3 minus 19 elevenths. But I just knew, look, from u sub 1 to get back to u sub 0, which is the y-intercept, I'm taking negative 3 and I'm subtracting the difference. Got it? No. Okay, here we go. U sub 1 is negative 3. Each time to get to u sub 2, I'm taking negative 3. I'm adding 19 elevenths. The y-axis is where x equals 0. Got it? So, to get to u sub 2, I took u sub 1 and added it. So, to get to u sub 0, I'm going to take u sub 1 and I'm going to subtract the difference because I'm going backwards. Got it? So it's negative 3 minus 19 elevenths, which is negative 52 elevenths. That's the y-intercept. The difference is always your slope.
Is there gonna be one like that one?
Yes.
Wait, but so
You can just use the formula if you cannot reason that, but y'all need to be able to think the slope, that's my difference, change in y over change in x. That's my difference, which we've always called the slope. This is my y-intercept. That's when we are at u sub 0. When x is 0. This sub number is on the x-axis.
feel like if it wasn't 19/11ths and it wasn't 52/11ths, it would make more sense. I'm just like, the
So
numbers
what
just
was the
like-
answer?
Like
Well,
it
you have to
makes
do
sense
this in
if
your
it wasn't
calculator. We haven't even gotten there. All right, I'll do it in your calculator. Math, go down. What is it? 78 is right. Okay, order of operations is going to be important. I got 78 as well. Let me see what you put in your calculator.
Sometimes like a worry
You have parentheses, or you should have parentheses on the outside. Don't get rid of those. Open. 19 divided by 11. Close X. Minus 50 over 11. Yeah, got it. You got rid of those outside parentheses. Okay. All right. Now did you get 78? Okay, so don't get rid of those outside. I'm glad I came and saw. Don't get rid of your outside parentheses. 78. Does everybody understand this?
Everything goes inside of parentheses, right?
Chat, I got 16.
When you do the summation, parentheses are there. Yes. Don't get rid of those parentheses.
At least I can say it's finished.
Okay, guys, we are going to go over today. We are going to go over the time.
Okay. That's how.
I mean, if you have to leave, you have to leave. Got it? All right, but at this rate, we haven't finished chapter 1 review. All right, let's keep going. We did a lot from chapter 2, but
Chapter 2 is more fresh too.
it's fresher. Yes. Okay,
Oh wait, are we not gonna finish it?
look at 49. Can you sketch a scatter plot with x equals 0 corresponding to 1990? Okay, it's dots. So what would be the coordinate points? The coordinate points would be 0, 5.6. What would be another coordinate point? 1, 6.8. Does everybody get this? What would be the next coordinate point? 2, 7.5. 3, 6.9. And y'all can plot those. It's 49. You got it? So you're just going to draw this. 0, 1, 2, 3, 4, 5. Label your graph. And it goes, I would label it by ones here. Remember, we're deciding what we wanted to label it by. It's just okay to do ones. 5, 6, 7. So 0, 5.6. 1, 6.8. Got it? And so forth.
So they're all gonna be in the same area.
Everybody understand that? You're just going to have dots.
Dot.
You got it? Everybody can
You
do a
don't put-
scatter plot?
You don't put the year.
Never do we put the year. Why? We always said you start at 0 or you start at 1. One of the two.
If we don't put that in our calculator, we can just do it like that.
No, I'm not grading what's on your calculator.
How do you enter the thing? Wait, stats on me.
Okay, look at 51. What's the y-intercept of the graph? How am I going to do that for 51A? Find the y-intercept.
Put the x intercept 0.
Make x 0! Yes.
So you just rewrite the whole thing and put 0?
make 0 for x. Exactly.
Wait. So x-intercept, y-intercept is your x equals 0, so just enter 0.
Enter 0. Yes.
All this.
1 equals y.
Yes.
What is the slope?
What is the slope? How are we going to figure out the slope?
Forget what x is when y is 0.
How about make it look like y equals mx plus b?
Wait, how do you scatter something? In all caps.
This is the same thing as right? We said the y-intercept was 1. What's the slope?
Zero?
And x equals 0, so it's 1.
1. We have two like terms. 1 minus 1/5 gives me
I thought x equals 0.
nope, that was for the y-intercept.
So
We were finding the slope. Got it?
Okay. Wait, I don't understand. We were finding the slope. They all say
That's why we are making this original equation look like y equals mx plus b.
So where did x equal 0?
That was part A. That's the y-intercept. So this is B, 51B. In A, we said make x 0 to find the y-intercept. That was A. All right, how do we find the equation of a line passing through that point with the slope of 3?
y minus 1.
What formula are we using? What form of the linear equation? Point,
Intercept.
slope.
Slope and
Point, slope. Y minus -1, which is plus, equals the slope times x minus 2. That's y minus y1 is the slope times x minus x1.
So then we just distribute.
Just distribute and make it look like y equals mx plus b. All right, guys, can we move on? I feel like I'm rushing y'all.
Just, I know,
But that
yeah, we can
one's
move on.
Okay, look at 55. How do I find the y-intercept of that line?
Make x 0.
Make x equal 0. Got it? So 55A would be 2 times 0 plus 3y minus 4 equals 0. That's 0. You have 3y equals 4, y equals 4 thirds. So it's 0, 4 thirds is the y-intercept.
If it said like, we'll ever say find an x and there's y's in there, so you just change those to 0 too.
We never change, wait, say that one more time.
If it asks for the x. And
X-intercept, if it asks for the x-intercept.
Y will equal 0.
Y, set y equal to 0, yes, yes.
Parallel means same.
Okay, B, how do we find the equation of a line that goes through 1, 3, and has that same y-intercept?
So it points up and then.
We don't have the slope.
Oh wait, no, we just do.
You find the slope.
However, we have y equals mx plus b.
We also have y1 minus y2 x and x.
We know what b is. So you just substitute x and y in, solve for the slope.
Wait, is it the same slope as the other one?
No, we don't know what the slope is. We just want to find one that goes through this point that has that y-intercept. So it's 3 equals m times 1 plus 4 thirds.
We want to fit.
Solve for the slope. Y'all tell me what m is. M is 3 minus 4 thirds. That's 9. So m is 5 thirds. 9 thirds minus 4 thirds.
Yeah, but if you have 2 points and you want to.
You only have 1 point for 55B.
Oh, I'm sorry.
55B. Yes, for 55B. So it's y equals 5 thirds x plus 4 thirds. Ladies and gentlemen, do you understand this?
Yes.
You got it? Okay, you've probably not been asked a question like this, but you have to think, what information do I have and how can I solve it? I didn't have the slope. I couldn't use this formula because I don't have the slope. But I could use this formula because I have an x and a y and I have the y-intercept. So you have to ask, what information do I have? And that dictates what formula you use. All right, 57. Find the equation of a line through -4, 5. So this is 57. So we're going through -4, 5. And we want it parallel to a line through those other 2 points. So what do we do?
Find the slope.
Find the slope of the other line because parallel lines have the same slope. All right, so it's 2 minus 3. It depends on how. It's 2 minus 3 over -4 minus 1. That's -1 over -5. So the slope is 1/5. And then I have this point. So it's y minus 5 equals 1/5 times x plus 4. Everybody understand that? It's this formula here. Once I calculated the slope, the line parallel to it has the exact same slope.
So then distribute.
Distribute and do it, right? We don't need to do that. You can do that. Are we good?
Yes.
59. Point UV lies on the line. On that line given, y equals 5x minus 10. What is the slope of the line passing through UV and the point 0, -10. Oh, y'all, that's such a crazy question. Point UV lies on that line. Y equals 5x minus 10. What is the slope of the line passing through UV and point 0, -10?
Wouldn't you just do the change in y over the change of x?
Both of those points lie on the same line.
So it's just 5.
So it's just 5.
Zero negative 10 is the intercept.
Yes! Is the y-intercept, which is in that equation. So the slope is 5.
Oh.
61. The graph has a y-intercept of 4. True or false?
What?
61.
Oh.
Well, I'd put it in y equals mx plus b.
It's true. Wait, actually, yes.
Yeah, it does. Because 8 divided by 2 is 4.
Oh.
Because then you divide every term by 2. And you have y equals 3/2 x plus 4. That definitely is the y-intercept. How we doing? We doing? All right, 63. The slope is not defined for horizontal lines. True or false? Here's a horizontal line.
False?
False, because the slope is 0. When is it undefined?
When it's
Vertical. Got it? 65. The line in the figure does not pass through quadrant 3. True or false? True, it does not. Okay, so jump to 68.
Wait, is it 1, 2, 3, 4, or 1,
It's
2?
1, 2, 3, 4. Go around this way.
Okay.
All right? 67. What? Aren't we on 67? No, wait. 68 is what I said. Which of the following lines does not pass through quadrant? No, y'all. 68. Which of the following lines is not perpendicular to that line? 68. Not perpendicular. Is A perpendicular?
No. Yes, it is.
Yes, it is. Is B perpendicular?
No. Wait, yes.
Yes, it is. You subtract x on both sides. Yes. Is C,
No.
I'm going to add 2x. I'm going to divide by -2. It is. Is D, what is perpendicular?
I mean, it's the opposite.
D is perpendicular.
Okay? So it's 1.
Reciprocal.
So it's the opposite reciprocal. So if it's 1/2, perpendicular is -2. If it's -3/2, perpendicular is +2/3. It's the opposite reciprocal. So if it's 1, then it's -1.
Yeah.
Oh, so it's
No, D is. E is not, because you add x on both sides and it's parallel. E is parallel. So the answer is E for 68.
Wait, how is
D is not.
It's gonna be a 70.
Look.
Oh, I got it. Yeah.
That's so good. Yeah.
Change all the signs. So that you have y is -x plus 1. Okay, y'all, I'm working D. What I do wrong was D. Negative, negative, positive.
D is.
D is. Is D not, Hannah, you said D.
Is that right?
The answer is E.
Yeah.
Yeah. Because if you.
Oh, because this one is perpendicular, which is not perpendicular. No. Okay. Never mind. Okay, 71. Can y'all do it's E. 71. Can we find the y-intercept? By now, y'all should be able to do that.
0?
Make x 0.
So, negative 3y equals negative 5
Whew, it's been crazy. But we've still got to get to geometric. We've got to get to geometric.
Okay, we understand these. We can move
But
on.
85.
Let's move on.
We know how to do slope, guys.
71 is 5/3. Okay, 85. Are we finally in?
We're in section 1.6.
Yes, finally.
Wait, where are we? What number?
85.
Page 75.
Page 75. Okay. All right, U1 is 2. The ratio is 3. Find a formula for this. All right, so when it says find a formula, you always want the explicit yes.
Why not the other one?
Because why do we not care so much about recursive?
Don't you need the term right before it?
Because you need every sequential term. But if I had the explicit, I could say, what's the 100th term? If it's recursive, I gotta go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I gotta go all the way up. Got it? So that's why the explicit is better. Okay. How do I do this? UN
Equals U2
2,
R3
3,
3 squared. Wait, and minus 1.
and minus 1.
So and minus 1.
Got it?
So that's the answer.
That's the answer. Okay, 87. We have U2 is 192. U7 is 6.
Well, we can find the thing.
How do we find the thing?
Finding the slope.
This is geometric.
Wait, does that only work for geometry? Wait.
Okay, so everybody watch. I'm going to do U sub 7 divided by U sub 2, but I'm going to take the 7 minus 2 root.
Wait,
Oh, because you can't do the easy.
We did. It's been a while.
why can't you just do the slope thing?
Because
it works
this
like
is not linear. This is geometric.
That's so sad.
Slope only exists in linears.
I don't even get
This is geometric. Geometric is not,
But it's not.
it says.
Geometric uses rate.
Assume that the sequence is geometric. Okay, so it's the 5th root of 192 divided by 6.
Is that on the equation sheet? Is there an equation sheet?
The chapter reviews have,
1.6 probably
I taught this,
has. Just write it down.
but you can write this down. That will give you the formula. And it's any sequence, all right? What is this?
2.
It's 2?
Two. I think
Did anybody else get 2?
what? 5? What's yourself?
192 divided by 6. Then I'm going to take the 5th root. You got to go to math. 5 Oh yeah, it's the fifth root of 32 is 2. It's the fifth root of 32 is 2. Because 2 to the fifth is...
How do you do?
Okay, how do you do the fifth root? You go to math and go down. Got it?
Oh, 5.
So that's my R value. 2 is my R value.
To be on that, just go to math.
We're on 87. I'm glad I wrote this down. Okay. So now I need UN is U1. Yes. I need U1.
We use you too? Oh, we can do the thing.
Do the thing.
We can do the thing now?
So I can do 192 equals U1 times 2 to the 2 minus 1, or times just 2, right?
And then we move that to the
So
side.
it's just divided by 2.
Wait, guys. It's 1/2. Look, I did this wrong. I wrote this wrong. We're going to keep working it like this.
Is this all in one?
But I wrote U2 and U1. It's okay. It's okay.
How do we know which goes where?
Well, I said here, the higher one goes in the numerator. So it's 1/2. Dag nabbit.
So
Okay, let's go back. Everybody look. Here's where I made a mistake. I wrote U2 in the numerator and U7 in the denominator. It should have been 6 over 192, which is not 2, it's 1/2.
Yes, that makes sense.
Okay?
why'd you write 2R?
1/2 equals the ratio.
Oh, equals ratio.
Yeah. All right, so this is 1/2 now. So this is 1/2 to the first power. So really we're just multiplying by 2. So that U1 is, what's 2 times 192? That's 418.3.
Wait, times 192?
Yeah. So now we have UN equals 384 times 1/2 to the n minus 1 instead of 2, because I did that upside down. All right, look at 89. Can we do the partial sum? All right, how do we do the partial sum?
We find the
The explicit. Okay, we find the explicit. What are we given? We're given, it's arithmetic.
Oh, we're giving you 1, we're giving -2.
Let's do number 90. It's geometric instead. All right? So we're giving you 1. It wants the fifth partial sum. And we're given 90. U1 is 1/4. And the ratio is 3. All right, so if I just come up with the explicit form, then it's UN equals U1 times the ratio raised to n minus 1. If I put this here, then I can get the kth partial sum.
So now something.
Now put that in your calculator. Yes. If you need to go, I understand totally. I get it.
Are you gonna post these videos?
Yes. And I also feel like I have another video somewhere. 1 to 5. And it's 1/4. And I'm going to put 1/4 in parentheses. Times 3 raised to the n minus 1. Okay, I get 30.25. And I'm going to do math num num. Yeah, that's the answer in the book. 30.25.
So just 91.
All right? Okay.
Do y'all get 30.25?
Yes, ma'am. Real quick, let's look at chapter 2. Can y'all stay? Hang with me about 15 minutes? Can y'all hang with me about 15 minutes?
Okay, yeah, just miss.
Okay, go to page 135. Go to page 135. All right. Oh, I went past page 135. Okay. Look at 1 through 4. I won't tell you on an interval. I'll just tell you to solve it. All right, so we're just going to walk through this. Number 1, I would put x cubed plus 2x squared in y1. In y2, I'd put 11x plus 6. And I do second trace intersect. Got it?
Oh, so you put, but I thought that's what you didn't like as much.
I don't like it as much. So you could set it equal to 0. So you could put x cubed plus 2x squared minus 11x minus 6 and graph it. And then you do second trace 0.
Okay.
Not intersect.
Got it?
Not
Oh, I like that one better.
Me too. All right, that's 1 through 4. If I'm solving for 5, y'all just listen quickly. If I'm solving for 5, I'm looking for zeros of the numerator. So I'm only putting the numerator in my calculator in y1. Only the numerator. I'm finding the zeros, and then I'm making sure those zeros don't make the denominator equal 0.
By just putting it in.
By just putting it in, yes. If I have a radical like number 7, I'm not putting the radical in my equation because the square root of 0 is 0. So you just look for the zeros of what's under the radical. Just put what's under the radical in y1.
Point number 7.
So zeros, when you're talking about the number 5,
Yep.
would you do second trace 0?
For just the numerator.
Right,
For
for just the
just
numerator.
the numerator.
And then you would
Find the zeros.
what are,
Second trace 0. So where it crosses the x-axis.
Yeah. It only crosses it once.
And then I'd find that one, and then I'd substitute in the denominator to make sure it doesn't make the denominator equal 0.
And then for number 7, what did you say to do? Only what's under the
Only what's under the radical.
Wait, is there anything else then that we can do?
Don't use the radical. It makes it look
Oh,
very
yeah.
strange. Don't use the radical, okay? Look at number 9. Y'all can factor number 9, can't you?
Yes.
You can, yes.
Would you just have 3x and then x? Or do you have to do something else?
I would say factors. I'd probably, if it said solve for x, I would use the quadratic formula immediately for that. Because it didn't tell me what I had to use. I'd use the quadratic. Got it?
When you use the quadratic, does that give you x or y?
That it depends on what you're solving for. There's x's in here. That gives me the x's.
Okay, and if it's solving for y, just give y.
Yes. Like number 10,
Yeah.
I'm now solving for y using the quadratic. Number 11, I'm now solving for z using the quadratic. Got it?
So if you put that on our test,
I'm only going to put x.
okay. So we can do whatever we want, but it would be smart to.
So jump down to 15. Okay, look at the question. Find the number of real solutions. What is this question not asking for?
Not irrational.
It's not asking for imaginaries. It is asking for rational and irrational. Those are both real. But it says find the number of real solutions.
What would make
When it says find the number of real solutions,
like you're giving them not the actual solution, but the number of solutions.
that's right. I'm looking at the discriminant.
And what does the discriminant give you?
How many and what types of solutions?
So if when you do the discriminant, you get 2.
Greater than 0, 2 real. Equal to 0, 1.
Oh, we need to know that
Real.
one.
Yes. Less than 0, 2 imaginary. And I want to know, are these real or rational? I mean, rational or irrational?
Wait, we don't do the square root of, it's like,
Not if it says how, listen, look at what the question is asking. Find the number of real solutions. Not what are the real solutions, but find how many real solutions there are. You're always using the discriminant.
that's the discriminant.
This is the discriminant, what's under the radical of the quadratic formula. That's the discriminant.
And whenever we were in class earlier, we were like, you need to know the discriminant. That's
I
what-
did, that's the
That's what you
discriminant.
meant.
That's the discriminant.
E squared minus 4.
Wait, what are the different parts of the quadratic equation? I know you have the discriminant. What's the other thing?
Okay,
What's used
Do
it?
we need
That-
to know those?
that's when we graph. That's the x coordinate of the vertex.
Oh, okay.
The x coordinate of the vertex is the opposite of b over 2a. All right, so a is 20, b is negative 31, c is 12. What's negative 31 squared? Y'all help me. Minus 4 times 20 times 12. What's negative 31 squared?
961.
961 minus what is this?
4 times
20 times 12.
960.
960.
That's crazy. So then it equals just
It equals 1. So that is going to be 2 rational.
it's greater than.
Wait, what?
Why is this going to make rational?
Because it's greater than 0.
Because it's a perfect square.
That too.
It's going to be rational.
How do you get 1 and it's 2 rational?
Because greater than 0, 2 real. Because it's 1, it makes it rational.
So our answer would be 2
Rational solutions.
rational solutions.
If it were 3, it would be 2 irrational. Only if it's a perfect square and it's greater than 2. If it's negative, there are no real solutions. If it equals 0, there's only one rational solution.
I don't know.
Wait, Miss Paul. It's
Yes.
at 3, but isn't that still greater than 0? So
There's still 2 and they're real, but it's not going to be irrational. Because y'all, this is under the radical. It's going to be the square root of 3. That's irrational.
Oh,
But the square root of 1 is 1.
Correct.
you just say
All right, jump down to 23.
ergo.
Can y'all work problems like that? A square region is changed into a rectangular one by making it 2 feet longer and twice as wide. So what happens? We take we take the side and we make it 2 feet longer, and this one is twice the width of the square. 23. This is number 23.
The square?
Originally it's square, and we're changing it to rectangle. And how are we changing it to be a rectangle? we're making it 2 feet wider, 2 feet longer, and twice as wide. If the area of the rectangle, that's the area of the rectangle, is
So it's 2s squared plus 4s.
I'm just leaving it like that for now, is 3 times larger than the area of the square, 3 times the area of the square. What was the length of the side of the square before it was changed?
So what is that?
What is S? So actually, you could just put S plus 2 times 2S minus 3S squared. You could put this in Y1, do second trace 0.
Are you gonna use S as a variable on the test?
Okay, when your calculator gives you an X, it doesn't matter. You just know what, yeah.
Could you technically also do the top one and do y1
I never
and
did
y2
that.
and then try some percent?
Yes, you absolutely can.
That's the first one.
Wait.
Yes,
Why did you get equal 3?
because as I read, I wrote, it said the area of the rectangle, that's the area of the rectangle, base times height, is 3 times larger than the area of the original
Okay, and
square.
then you just subtracted that and then you could put that into y1.
Y1,
And do second trace 0.
yes. And actually, y'all, this is a second degree, so if you multiplied it out, you could use the quadratic formula. All right, 23, look at 28. All right, this is absolute values. How do we deal with absolute values?
You drop the bars.
Okay, ladies and gentlemen, come on, focus right here. Drop the bars. What else do we do?
Change the sign to the answer.
Drop the bars, change the sign.
And then you solve both.
Yes,
So x equals.
it is. You want to know what time it is? 2:20.
And
about.
X equals -6.
All right, y'all can do those, right?
Wait, so what do I do with the answer? Do I just write x y equals 2?
X equals those values, yes.
Do I have to check it?
You don't have to check these. Here's what you have to check. Jump down to 28. We're at 28, Paula. 28, 29, 30, 31, they're all the same. 32. You have to check something like 32 because it has an X outside the absolute bars.
How do you check it?
You substitute your solutions back into the original equation.
Okay, just make sure.
Yeah. Okay, do y'all know how to work 33?
Wait, on 32,
Yeah, let's do it.
would you be changing it? Would it be x minus 4 then?
It'd be negative X minus
Negative
4.
x
So you drop it, 2X minus 1, X plus 4. You drop it, change the sign of the entire term.
Okay. Negative x minus 4.
Yes.
Okay, for
2X minus 1 is negative X minus 4.
33.
So that X is 5. 3X is negative 3. X is negative 1. And make sure both of these work. Make X negative 1, does it work? Make X 5, does it work?
For 33, do you just square both sides? If you're still getting.
Yes. You don't really have to because what's under the radical where it equals 0 is equaling 0. Here's when it matters. It matters like on, let me get my page there. Like on 39. I also want to work 35. I want to do 35 and 39. Y'all, this is going to be such a long video. I'm going to edit out maybe the 1 ones we didn't need to. I don't even know how to edit it, but I'm gonna try. Okay, what I say I wanted to do, 35 and 39. Okay, 35, x squared minus 6x plus 8 over x minus 1. Remember, the zeros are only the zeros of the numerator, so I'm going to factor the numerator. That's x minus 4 times x minus 2. The zeros are 2 and 4, because those are all not zeros of the denominator. If I would have had if it would have been this, my only zero would have been x equals 4.
Okay, did we skip through 33? Because I still don't. I understand 35, I just don't understand 33. Once you do it, you get x squared.
You can square both sides, but 0 squared is 0.
I know, but then you get x squared.
X squared minus x minus 2 equals 0.
And then what do you, that's just the answer?
No. So factor it. X minus 2 times x minus 1. X is 1 and 2.
Okay.
What? One's got to be plus. Hello. Plus. So negative 1. Because a positive, negative times a negative gives me a positive. That didn't work. This is 33. 33. Okay, do y'all want to work 37 or 39? Okay. Square root x plus 1 plus square root x minus 1 equals 1. Move 1 to the other side. I'm going to move this second term over. So it's square root x plus 1 is 1 minus square root x minus 1.
Why can't you just square the whole, like both sides?
You can't. Because it's that times itself. You're going to make it bigger. You're going to have x plus 1 times x minus 1 and x minus 1 all under the radical. You can't. Isolate 1. Because when I do that, it's
Oh, you're right.
got it?
Okay.
No, you're still going to have more radicals. You're going to end up with more radicals. All right. Now we're going to square it. On the left-hand side, it's just x plus 1. The right-hand side is that.
Just then you foil.
Foil. You're going to end up with 2 of these. That's what you're going to end up with. There's 1 negative, and there's another negative to make 2 of them. And a negative times a negative is a positive, and the radical is just x plus 1. All right, so my x's are going to eliminate. I'm going to add, my 1's eliminate here, huh? So then I just divide by negative 2. Okay, y'all look at this. Negative 1/2 is the square root of x minus 1. Is that possible?
For it to be negative.
Yeah, is this possible?
I think the answer's
The answer is no, but why is this not possible?
it's under radical.
Right. You can't take the square root and get a negative number.
Meaning,
There's no solutions.
are there going to be possibilities of no solutions on the test?
Yes, you have to. So if you kept solving for this and you got your answers, okay, you could keep solving and get the answers. Okay? Squared,
But we don't have to because we know.
squared, right. 1/4 equals x minus 1, add 1, 5/4 equals x. You go back in and substitute it to the original equation. It doesn't work. You always have to go back in and substitute it. Anytime you square any side, you have to always check your solutions. When we have absolutes and an x outside, check your solution. Always when you have problems like this, check your solutions. All right? Y'all can do interval notation, right? Okay. 37, 39, 43 through 45. Y'all can do inequalities. Yes. That's 2.5. Can y'all do 45? Number 45.
You solve it.
Let's do number 45. That'll be it. We did one similar to this. Move the one to the other side. Less than, I'm telling myself below the x-axis. Common denominator. That negative is distributed to both. So that's negative x minus 2 over 3x plus 1 less than 0. So we know something happens at negative 2, that's the 0 of the numerator. And we know, what is that, negative 1/3. So you graph this and look at what's below the x-axis. But you know these numbers are what you're going to use. But it can't equal that one because that one's in the denominator. Okay. I need parentheses.
Are you going on y equals?
Y1, yes. Negative x minus 2 in parentheses divided by 3x plus 1. I just want to see those x. What happens at those numbers? Okay, so below the x-axis, this is what I get when I graph it. No, this is what I get. Yeah. Mine's closer in. This is what I get.
Okay.
So it's below the x-axis,
What did you put into that one?
parentheses, divided by
Oh yeah.
that. All right, so it looks like this. Here's negative 2. It comes like this.
So negative infinity and negative 2.
And then here's negative 1/3. And we don't see anything, but we do see this.
And then negative 1/3 is positive.
Yes. So it's negative infinity up to negative 2 and negative 1/3 to positive infinity.